Assalamualaikum and hi everyone. Welcome back to my channel. How are you today? I hope you are doing well and excited to learn physics with me. Today, we are going to learn about alpha decay, beta decay, and gamma ray in 15 minutes. Before we go deeper into this topic, let's look at our objective for today's lesson. At the end of the lesson, students are able to explain with examples the decay equations for alpha decay, beta decay, and also gamma ray. Next, let's see what is the introduction for radioactive. Okay, first, we need to know what is radioactive decay. Radioactive decay is a process in which an unstable nucleus becomes more stable by emitting radioactive radiations. So, what we need to learn is about radioactive radiation and also the process of radioactive decay. It means that when the radioactive decay happens, they will produce radioactive radiations such as alpha, beta, or gamma ray. So, let's see the example here. This is one of the process of radioactive decay. This is the parent isotope and it is unstable nucleus. Now, the parents will do the process of radioactive decay and it will produce the daughter isotope which is more stable nucleus, and it also will produce either alpha, beta, or gamma. These are the three types of radiation produced. This process is random and spontaneous. It means that we don't know when they happen, and this process also does not affected by physical factors such as temperature or pressure. Let's look at the types of radioactive radiations. The first radioactive radiation that I will introduce is alpha particle. Alpha particle is a helium nucleus which consists of 2 protons and 2 neutrons. The second radioactive radiation is beta particle. Beta particle is a fast-moving electron. And the last radioactive radiation that I will introduce for today's lesson is gamma ray. Gamma rays are high-frequency electromagnetic waves. Next, let's see the explanation of alpha decay. What is alpha decay? Alpha decay is unstable nucleus release an alpha particle to become a more stable nucleus of a new element. We also can write the equation for alpha decay as shown in the slide. X here is the parents, A is nucleon number, and Z is proton number. These unstable parents will undergo the radioactive decay and will produce the daughter which is more stable nucleus, and it also will produce the helium, or we can call it as alpha particle. As you can see, the nucleon number of daughter mass minus 4 and the proton number of daughter mass minus 2. It means that after decay, the proton number and the nucleon number of the daughter plus the radiation together, they will become original. This is the example of alpha decay where plutonium-240 undergo the radioactive decay and produce uranium-236. That means they will come out with one of the helium, and if you remember, the helium is actually the alpha particle. How to write the equation for this example? Let's look at this explanation first. Parent nucleus, which is plutonium, has nucleon number A 240 and proton number Z 94. After alpha decay, the daughter nucleus, which is uranium, has nucleon number A-4, which is 236, and proton number Z minus 2, which is 92. We can refer to this general equation to write the equation for this example. We can change X with plutonium 240 for nuclear number and 94 for proton number. And when plutonium undergo the radioactive decay, it will produce uranium 236 for nuclear number and 92 for proton number, plus the helium, which is alpha particle. You can see here, if the nuclear number of uranium plus the nuclear number of helium, you will get the original nuclear number, which is 240. And if the proton number of uranium plus the proton number of helium, you will get the original proton number, which is 94. So this is how we write the equation for the alpha decay. Now, let's look at what is beta decay. Beta decay is a neutron in an unstable nucleus decomposed into one proton and one electron. The resulting proton remains in the nucleus, while the electron is emitted with high kinetic energy as beta particle. This is the general equation for beta decay. X here is unstable nucleus. When they produce the stable daughter, the nuclear number A is maintained because beta there is electron. They don't have any nuclear number. How about the proton number Z for daughter nucleus? So, proton number for the daughter nucleus need to plus 1, and for electron you need to minus 1. So Z plus 1, then minus 1, then they go back to the Z. That means the nuclear number and proton number must same with the original. This is the example of beta decay where carbon-14 undergo the decay process to produce nitrogen-14 and also the beta particle. After beta decay, the proton number of daughter nucleus becomes Z plus 1, but nuclear number A does not change. Let's look at this general equation for beta decay. To write the equation for this example, we can change the X with carbon, which is C, 14 for nuclear number, and 6 for the proton number. After it undergo the decay process, it will produce the daughter nucleus, which is nitrogen. And also, it will produce the beta particle, which is electron. The nuclear number for nitrogen does not change, but how about the proton number? The proton number, Z, will be plus 1 and it will become 7 for the nitrogen. Now, let's look at what is gamma decay. Gamma decay is an unstable nucleus release its excess energy to become more stable. Gamma rays have no mass and are neutral. This is the general equation for gamma decay. If we see here, the nuclear number, which is A, and the proton number, which is Z, does not change. For the gamma decay, they just produce a large amount of energy. Let's look at the example of gamma decay. After gamma decay, there are no changes in the proton number and nuclear number for the nucleus. The nucleus is less energetic after gamma decay. This is the general equation for gamma decay as we have discussed just now. Let's look at the example for the equation for gamma decay. CO6027 undergo the decay process to produce CO6027 and gamma rays. As we look at here, the proton number and nucleon number for the daughter nucleus does not change, but the nucleus will lose energy. For the next part, we are going to discuss on radioactive decay series. When an unstable radioactive nucleus decays, the resulting daughter nucleus may also be unstable. This means parent nucleus become daughter nucleus, and then the daughter nucleus still unstable, so that means the daughter need to continue to decay until it becomes stable. When the process just continue, then you can imagine they will produce more energy and radiation decay. So, this process we call it as radioactive decay series. The daughter nucleus will continue to undergo a series of successive decays until a stable configuration is achieved. During a radioactive decay, some nuclei can emit more than one radiation. Let's look at the example of decay equation. The uranium undergo the decay process and produce thorium, helium, which is alpha particle, and also gamma. So this is the example of radioactive decay series, where you can see here there are two radioactive radiation, which is alpha particle and also gamma ray. Next, let's answer the questions that related to our lesson today to test our understanding. Question number 1. The following shows the equation for radioactive decay. Ra22688 undergo the decay process and produce Rn22286 plus X42 plus Y. So, the question is identify X and Y in the decay. So, let's answer the question. Let's think first. Okay, the answer is X is the helium nucleus, or you can say alpha particle, and Y is gamma ray. This is the answer for the question number 1. Next, question number 2. Complete the radioactive decay equation and identify A, B, and C. Let's look at the question. For A, Ra22888 will undergo the decay process and will produce A plus beta particle. For question B, Po20984 will undergo the decay process and will produce Po20582 plus B. And for C will undergo the decay process and will produce proton plus beta particle. So the question needs you to find the radioactive decay equation and identify what is A, what is B, and what is C. For this question, I will leave for you to complete at home. If you are able to complete this task, it means that you have achieved this learning objective for today's lesson. That's all for today. See you in the next class. Thank you and have a nice day. Bye.